Jai Hind everyone, my name is Amrita Bhatnagar. I am from CSE department of Akgec. Today I am going to explain Cocomo model of software engineering subject. Okay. So firstly, these all are the outlines of the subject or topic. First one is the introduction to the Cocomo model. Firstly, we will understand what is Cocomo model. Then next is the different types of the Cocomo model, which are basic model, intermediate model, and detailed model. So firstly, we will understand what is the Cocomo model and why it is used. Okay, what is Cocomo model? The Cocomo model is a procedural cost estimate model for software projects and is often used as a process of reliably predicting the various parameters associated with making a project such as size, effort, cost, time and quality. It was proposed by Barry Boehm in 1981 and is based on the study of 63 projects, which makes it one of the best documented model. So this is the cost estimated model, and the full form of the Cocomo model is cost constructive model. So by the help of Cocomo model, we can find out the cost of our project, or we can say that we can estimate the proper cost of the our project, software projects. So now you can see here the full form of the Cocomo model is constructive cost model. It is the hierarchy of software cost estimation models, which include basic, intermediate and detailed submodels. So we have different type of cost constructive model. First one is your basic model. First one is the basic model, and second is the intermediate, and third one is the detailed model. So these all are the three different type of constructive cost model. Firstly, we will understand what is a basic model. Firstly is the basic model. Basic model, it aims at estimating small to medium size or software projects. Three modes of the development are considered in this model: organic, semi-detached and embedded. Now in the basic model, we will estimate the small to medium size of software project. Firstly, this is the first point, and we have three type of different modes in the basic model. First one is your organic mode. Second is the semi-detached mode, and third one is the embedded mode. Fine. So we will work in these three modes. Now we will understand what is the meaning of this three different type of modes. So you can see here. Here we will compare our three different modes. Firstly, first mode is the organic mode. Organic mode means when the size of your software project is around 2 to 50 kilo LOC. LOC is for line of code. So this is known as a small size project. When we have less number of lines, what it means, it is a small size project. And next is the condition is experienced developers in the familiar environment. And the next condition is the project is small and we have some developer who are experienced in the particular domain. The project belongs to which domain, it is familiar with the developers also. For example, payroll or inventory projects. So these all are the very familiar projects. So all the developers are familiar with this type of project, and the size of the project is not very long. So it is a very simple project. So we can say here the possibility of innovation is very little, because these projects don't have many complexity, or there is no possibility of innovation is less here, because these are the very familiar projects which is used by the different companies normally. Next, deadline of the project not tight. If we have a good deadline, we don't have less time, or we have good time in the project, then we can say that deadline of the project is not tight. Development environment, familiar and in-house. So next is the development environment. If it is familiar or in-house, then it is what it means, these are not the very complex projects. So we can see that, say that in the organic project we have some organic mode, we have some small project can be there, because the size of the project will be small, and we have some developers who are very much experienced in this domain. So it will be easy for them to develop this type of project. So but there is a less possibility of the innovation here. Less innovation, new techniques will be here used less. Fine. And next is the deadline is not tight, And next is environment is in-house environment. So these are the similar or simpler projects where we can which we can develop very easily. So this is known as an organic mode. The first is the organic mode. Second one is a semi-detachment. Now the if the size of your project is 50 to 300, what it means, now the these type of project comes under the category of semi-detached projects. Fine. In the happens in the semi-detached mode, medium size project, because now the size has been increased in comparison organic mode. So this is known as a medium size projects. Now next is the important thing is medium size team. The size of the team is medium. Average previous experience on similar project. Now we have some experienced persons for the project, but there is also possibility of different or different modules also there. There can be some innovative models or will be there, which are on which developers are not very much familiar. For example, utility systems like compiler. So compiler can be different from type. So these type of project can be under the semi-detached. Database system and editor. So there is some possibility of some innovative concepts also in the semi-detached, and the size of the projects will be increased in the semi-detached mode. Fine. So we can say innovation we have medium. The because in this case we have some more innovation in the semi-detached mode. In the organic, we don't have any innovative modules or innovative ideas not required, but in the case of semi-detached, because we have less experience in this field, so that why we need some innovation also there. Next is the deadline is also medium. What it means, there should be a given deadline. We have to complete the project on that time only. Development environment is medium. It is not in-house. It can be a different environment. So it can be another it can be another challenge for the developer. So because now the environment has been different. Right. Next, embedded. Now in the case of embedded, typically when the number of line of codes are over the 300 line of code. Fine, then so we can say that these are all those projects which are large projects, because now we have number of lines more. Okay. And real time system, these type of system can be real time systems. Complex interfaces, very little a previous experience. For example, ATMs, air traffic control. So these all are those projects which have more number of lines, but and the complexity of the project is more here, because we have some innovative ideas here. This type of project not already existing. That's why all the developer team is not aware with these type of projects. So there should be some innovative ideas should be there, and we have to develop it into the tight deadline. So these all are a project of embedded mode projects. Fine. So we can say the large project and the complex project are come into the embedded project, and the innovation will be here significant, because mostly in this project we need some innovations, because we don't have this type of project previously, which can be studied and which can be used for the experience. Next is the development environment. Development environment is complex hardware customer interface required. So the environment is also complex here, because we are not aware about the which type of environment can be used for this type of projects. So these all are the many challenges in this type of projects. So we can see that in the embedded type of project mode projects, we have large projects, we have complex projects, we don't have a previous experience in this type of projects, and the deadline of the project is also tight, and there should be some innovative idea should be there in the embedded projects. Fine. So these three types of category of the project which we consider in the Cocomo or basic models. First one is your organic, semi-detached and embedded. In the organic we use small projects, semi-detached we use medium sized project, and in the embedded we use large projects. So these all are the categories in the Cocomo model, in the basic model. Now these two formulas are used to estimate the effort and development time here. So you can see here E is for the effort, which is acquired, which can be calculated into person months, and D is for the development time in months. Fine. So these are the formula, and these all are the some coefficient which is already given in the Cocomo model. There is a table in the Cocomo model, and these coefficients are given for the each and different type of modes like organic, semi-detached, and organic, semi-detached, and embedded model. So we have different coefficient values here. Fine. And here we need size of the project. We put the size of the project here, and then we can estimate or calculate the value of effort. Then by the help of this effort value, we can calculate development time also. Now the next formula is for the average staff size. The average staff size can be calculated by the E by D, where E is the effort and D is the development time. When we calculate these two terms, then we can again calculate average staff size. Next is the productivity. Productivity also calculated by the size of the project in the kilo line of code upon effort. So, in this way we can calculate four terms. First one is your effort, second is your development time, third is your average staff time, and fourth is your productivity. Right? These four terms we can calculate in the basic model of the Cocomo model. Now, how we can have these coefficients? You can see by the help of this example, I can explain you how we can calculate these terms. Suppose that project was estimated to be 400 kilo line of code. So we have in this case 400 line of code which is given in the questions. Calculate the effort and development time for each of three modes. Now we have to calculate effort and development for these three modes. So I have already told you, in these three modes we have different coefficient value of A, B, B. You can see here. So you can see here. Firstly, we will start with the value of E. So we will put the value of kilo line of code 400, and then we will keep the value of AB here, which is 2.4 in the table. Now we will put the value of BB, which is 1.05 in the table, and we will calculate the value of E for the organic code. So these value for the different code will be different. If we use organic code, the value of AAB will be different, and if we use for the semi-detached, then the value of the AB will be different. And then when we calculate this effort, then this effort will be put in the next formula for the development time. Then we can calculate the development time of the project. Now next is the semi-detached mode. Again we will apply these two formulas in the semi-detached, but the value of these coefficient values will be different for the semi-detached. In this way we can calculate for the embedded mode also. So we have different table for the different coefficient value for the different type of modes. Okay. Now next example, again I am going to explain the next example of the Cocomo model. A project size of 200 kilo line of code is to be developed. Software development team has average experience on similar type of projects. The project schedule is not very tight. Calculate the effort, development time, average staff size, and productivity of the project. So you can see here, again we have the line of code, kilo line of code given in the question, but the mode of the project is not given in the question. So, but it is given that software development team has average experience on similar type of project, and schedule is not very tight. So we can say that it can be a semi-detached type of project. So we can apply semi-detached mode in this question. So again we will apply effort formula and development formula. When we find out the E and D, then we can calculate average staff size by the help of E upon D. We put the value of E and D, and then we can calculate the average staff size here. And the next thing is the productivity. Productivity can be find out by the help of kilo line of code upon E. Kilo line of code is 200 here, and the effort which already we have calculated here 1133.12. So we will put this value in this formula, and then we will find out the value 0.1765 kilo line of code upon person month. This is the answer of this question. So we can calculate all the four terms: effort, development time, productivity, and average staff size with the help of these all line of code and coefficient values. Now, the next model. So we have discussed about the basic model of the Cocomo. Now, next is the intermediate model. What is the meaning of intermediate? And there are some problems in the basic model. That's why we require intermediate model. The basic model allowed for a quick and rough estimate, but it is resulted in a lack of accuracy. So, by the help of basic model, we can find out the rough estimates, but this is not very much accurate. So that to improve the accuracy of our basic model, we need another model which is known as an intermediate model. So in the intermediate model, it includes the 15 predictors or cost drivers for the improving the accuracy of the basic model. So we will consider here 15 predictors, or which is also known as a cost driver in the intermediate model, so that we can improve the accuracy of the basic model. So almost formula will be same, but we will add on some most important cost drivers here. Cost drivers are used to adjust the nominal cost of a project to the actual project environment, hence increasing the accuracy of the estimate. So we can say that in the intermediate model, we will try to improve the results of the basic model by the help of using the cost drivers. Now the question is what it means, what is the meaning of this cost driver. So we will see here. You can see here, these all are the cost drivers here. First one is your product attributes. Required software reliability. So these all are the attributes of a product. For example, software reliability, size of application database, complexity of the product, hardware attributes, runtime performance constraint, memory constraints, virtual machine volatility, turnaround time, personal attributes, analyst capabilities, programmer capabilities, application experience, virtual machine experience, programming language experience. Okay. Next, project attributes, modern programming practices, use of software tools, required development tools. So see, these all are the major attributes of your project. So we will consider these all attributes in the case of intermediate model. So now you can see here, this is a table for the all the cost for all the cost drivers values. For example, these are the product attribute. So if we have first attribute, the value can be range from the very low to extra high. So all the values are given in this table only. So we will consider this table, and value we can take these values from this table, and then we can put these values into our formulas, and then we can find out the intermediate model's value. Fine. So these all are the cost drivers multipliers. So it can range from very high to extra high. You can see these all are the another attributes which we have already discussed, and the different values: very low, nominal, high, very high, extra high. So these all are the tables which have all the values of the cost drivers. Now we can see here how we can calculate effort in the intermediate Cocomo model. So this is the formula for the intermediate model. So we can see here the formula almost same. We will put here AI and or you can say AB or BA and KLOC. K is for the number of lines or line of code. Okay, and we will multiply here with the help of EAF, which is the adjustment factor, effort adjustment factor. So this is a new thing here which we will add in the intermediate model. So if by the help of this formula we have find out in the effort in the basic model, but now we are multiplying with the effort adjustment factor in the intermediate model to improve the accuracy of the effort estimation. Fine. Now the question is how we can calculate this EAF. So already we have discussed in the previous classes. We have different value A, B, Ci and Di for the organic, semi-detached and embedded. So we will put the values from the these table only, and then we will calculate the value of EAF also, and these EAF will be calculated with the help of 15 cost drivers. How we can calculate it? You can see here uh, uh, in the intermediate Cocomo model, extension of the basic model, which enhance more accuracy to cost estimation model result. It includes cost driver, product, hardware, resource, project parameters of the project. So these are all are the formulas which we have discussed already. So E is for the total effort, D is for the total time, K is the size of the code, and ABCD are the constant parameter of the software project. Okay. So we will see how we can calculate these values in this example only. So in this example, for a given semi-detached project, so in this question we have already given that the project is semi-detached project was estimated with the size of 300 KLOC. Find the size of the line of code is 300. Calculate the effort as schedule time for development by considering development having high application experience and very low experience in the programming. So these two cost factors are given in this question. We have already given that the developer have high application experience. So for the high application experience, we have value for you can see the experience application experience is high. For the high we have value 0.82. So we will put value here 0.82. And next parameter is given is very low experience in the programming. So experience in the programming we will see here. This is the experience, and very low, the value of very low is 1.14. So we will multiply these two factor and we will find out the EF or effort adjustment factor here. Now again we can calculate the value of E here. So we will calculate the value of E with the help of a line of code into effort adjustment factor. So you can see here with the value of effort here is 16,1668.07. Now again we will follow same procedure for find out the schedule time or development time of the project. So in the intermediate model we have a new factor here which is known as the effort adjustment factor, and which is based on the 15 cost driver values. So we have to find out this cost factor value and we have to multiply this factor and we have to find out effort adjustment factor. Then we will calculate if with the help of effort adjustment factor effort also. And again we can find out the four values of the or four terms of the Cocomo model. Now the next different type is next type of the Cocomo model is complete or detailed model. This is the third type of Cocomo model. The model incorporates all qualities of both basic Cocomo and intermediate Cocomo strategies on each software engineering process. The whole process is divided into different models and then apply Cocomo in different models to estimate effort and then sum of the effort. So in this case, in the intermediate, we have applied the concept in the whole model, but in the detailed Cocomo model we can divide the model into the 6 phases: planning and requirement, system design, detail design, model code and test, integration and test, and cost constructive model. So and we can apply different type for the estimation effort for different type for organic mode or detached mode or different type we can apply here. So if we can see in this case example, a problem statement is a distributed management information system product of an organization having offices at several places across the country can have the following subcomponent: database part, graphical user interface part, and communication part. So this is a MIS product which have sub-component database part, graphical user interface, and communication. So we have divided this project into three parts. Now we can apply different type of mode in the different component of the project. So for example, the communication part can be considered as an embedded software, and database part could be considered as a semi-detached software, and GUI can be considered as an organic model. So in the detailed Cocomo model, we can divide the project into different parts, and we can estimate the size of the project, and we can apply different modes of the Cocomo model in the different component. This is a detailed Cocomo model. So we have now discussed all the three models of the Cocomo: basic, intermediate, and detailed model. Now the next is the advantages of Cocomo model. Provide systematic way to estimate the cost and effort of a software project. Estimate cost of and effort of the software project at different stages of the development process. Help in identify the factors that have greatest impact on the cost and effort of a software project. Provides idea about historical projects. Easy to implement with various factors. These all are the advantages of Cocomo model, but we also have some disadvantage of the Cocomo model. It ignores requirement, customer skills, hardware issues. It limits the accuracy of the software cost. It is based on assumptions and averages. It mostly depends on time factors. Assume that size of the software is main factor that determines the cost and effort of the software project, which may not always be the case. So these all are the advantages or disadvantages of the Cocomo. So now we have completed all the topic. Thank you.